Okay, so first things first. So one thing I've noticed here is that you guys are, and this is fine, the way that most of you are getting to your assignments is by just going to quizzes to find the assignments you need to do, right? Which is fine. But in the process, you're missing out on something that I didn't want you to miss out on. There, with every one of these sections, and so if you look at, I'll kind of zoom out a little bit here. If you look at Unit 2, for example, it's set up in a way, very carefully, so that for each section there's going to be some reading that goes with it, and then I've indented the assignments so you can kind of see that there's a difference. Then are the assignments, right? And those aren't all for you. Some of those are for regular Algebra 2, some are for the honors class. In each case, though, you see this, you get this deal where there's reading and then there's assignments. So starting with, I'm not going to have you go back and do this, but starting with the new section, the last section in Unit 2, you'll notice that there is a new type of assignment called required reading check. Okay, and all that is, in order to be able to even do the other assignments, they're contingent on you doing this one first, right? So it just means that you have to go in and if you click on this one, here's what it looks like. So it's just one question, and it's going to give you're going to assign yourself credit for reading that section. I even link to it. So you don't even have to, if you want to, you can just go to the assignments and quizzes, and then if you click on the link, it takes you to the reading, right? And so if you pull this up, it's just a PDF. So for today, it's pretty straightforward and simple, right? It's just a flow chart. It's not even a reading. But usually it'll be a short section from a textbook. I try to make these as straightforward and to the point as possible, rather than have you have to go through and pick out the sections from the textbook that pertain to what we're talking about. I do it for you. Usually there'll be parts that I've just completely deleted, or there'll be parts where I've put a big red line through everything you can ignore. Just read the parts that I didn't cross through, right? And it's pretty short. There are a couple reasons I do that. I know that in a class like this where we got such talented students, you're able to probably go through and do the assignments without doing any reading. But it's not good, because in a math textbook, there's more to the reading than just being able to do the problems. There's some other parts of this where you're introduced to some vocabulary. There's some concepts that I want you to see, because later on we're going to come back to this, right? And here's another part of it. And I do think about this too. The research shows it very clearly, and this is pretty sad, but guess what the biggest predictor of success in college is? It's not SAT scores, it's not grades, it's the ability to read a textbook. Because like it or not, you're going to get stuck in some classes in college, and I had plenty of them, where the professor is going to be standing at the front of the room talking about stuff, and he's going to go through things and say, well, okay, we got through about a tenth of it, but now the rest of it's just in the reading. So you'll expect to do the reading and learn from it. But that happens all the time, where you're just going to have to learn stuff from a textbook. More and more colleges are doing online stuff like we do in here, where there's other types of resources available, which helps. But you're still, at some point, I promise you, at some point you're going to be in a college class where it's going to be you and a textbook, and that's it. Right, so you got to get used to being able to, wade through the language of a textbook. It's kind of academic language. You got to be able to extract information from a textbook. And so now it's time to start practicing. So you'll have these little assignments. They're short. You just assign yourself credit. I mean, they count as homework grades, so it's a pretty easy homework grade. But that's something we'll be doing for the rest of the year. Okay, for today, what I want to do real quickly is I just want to go through a couple practice examples to make sure very few. Then I want to let you get going on working in class. So let's do this one. Let's look at an example, and I'm going to force you to do this one, think about this one with completing the square. It may turn out that this is not really a good candidate for completing the square. Maybe we choose some other option. But for today, let's just do this by completing the square. So let's talk about the steps here. There's a couple things I want to emphasize. So what would we do first? So we raise a hand. Now you're trying to raise a hand. Oh, you weren't? Okay. You sure?
+1.
Okay, you could add 1. And I understand why you do that. There's something else I would have you do first though, what do you think? Divide by negative, okay, you could divide by -2. I would even have you do something even a little different than that, it makes it a lot simpler. Say it again? Yeah, let's multiply both sides by -1, how come? Good, so we want a to be positive. We always want a to be positive when we're solving a quadratic equation. It makes life a lot easier, no matter what method you use, it's always going to be a good thing to do. So before we even think about completing the square, the first thing we'll do is change the signs. Multiply through by -1, and what's that give us? What's next? Good, now we'll do the problem, right? Now that we've got a positive a, it just makes life a lot easier. So now to complete the square, first step, you already said it essentially. Subtract 1. Oh my, what happened? I don't know. Okay, now what? Divide by 2, I heard, right? Because we got it. Remember, our goal is, in order to complete the square, we've got to get this in the form x squared plus bx equals some number, right? So we need the coefficient of x squared to be 1. So we divide everything by 2. I'm dividing multiple terms by 2, so I'll just divide each one separately, right? And what's that give us? Okay, so x squared minus 7/2 x equals -1/2. Okay, now remember, when we complete the square, we're breaking this into 2 parts, right? We've got our we're at the starting line for completing the square. There's step 1, but we'll also start step 2, right? What am I going to write in step 2? What's the first thing I'll do? Parentheses. Right? Before I even think about it, I'm just going to set up the template, and now I'll fill in the blanks. So what's the first thing I do here? Let's close that up. It's the first thing I do. So step 1. Half of 7/2. What's half of 7/2? 7/4. It's half of -7/2, so it's -7/4, right? So step 1 is I get -7/4 there. So I already know what my perfect square is going to be, right? It's going to be x minus 7/4 squared. And all I need now to make this a very simple quadratic equation to solve is I just need to know what goes there, right? Okay. How do I find that? What's next? So that's step 1. What's step 2? Okay, good. So step 2 is I'm going to fill in what I'm adding to both sides, right? Which is b over 2 squared. So that's, what is -7/4 squared? So I'm adding 49/16. Obviously, that number is always going to be positive, right? Because we're squaring something, right? And then finally, step 3, we're finding out what is the number we're stuck with on the other side. So we got to combine these fractions. What's my common denominator going to be? 16. Okay, so I'm going to multiply top and bottom by 8, and I'm going to get 49 minus 8 over 16, so what, 41/16? And now it's easy, right? Now this goes back to one of the first kinds of problems we ever did, this section. We've got a single x that we can point to, and so we just isolate x, right? What would the 2 steps be in order to get x by itself? Square root. Okay, so if we're going to solve this, we get x minus 7/4 equals, okay, but what do I got to write first? Plus or minus square root of that, right? So that's going to leave us with square root of 41 on the top and 4 on the bottom. And we try to reduce that, but 41's prime, so we're not going to be able to reduce that. We're stuck with that. And then last step, add 7/4. So we get x equals 7/4 plus or minus square root of 41 over 4. Those are our 2 answers, right? No big deal. And that's about as hard a one as we get for completing the square. Okay, what about if we're solving with quadratic formula? We wouldn't even have to do this one necessarily, but what would be Okay, let me change this. I didn't mean for it to be quite that easy. What if this were like 25x instead? What am I going to do before I even think about this? Change the negatives, right? We're going to make sure a is positive, so we multiply both sides by -1. We get 4x squared minus 25x minus 56 equals 0. We would try to...
Plus 56.
Plus 56, good. So we would try to maybe divide both sides by a factor if we could, but we can't. There is no greatest common factor. So now this is just quadratic formula stuff, right? We'll just plug and check, plug into the quadratic formula and see what we get. Do you want to go through one of these, or are you okay with quadratic formulas? Okay, we good with that? If you have questions, you can come on up. But I think you're probably, seems like people are in pretty good shape on that. One thing, okay, so maybe I'll make one other point. So what if we did have, okay, what if it was, I changed it, pretend I didn't change it. So say we turned this into positive 4x squared minus 24x plus 56 equals 0. What is something we could do there? Okay, we could factor out a 4, couldn't we? Right? Now I want to show you kind of a shortcut here. So we'll take two different roots with this. So one root would be to factor out the 4, and what are we left with? X squared minus 6x plus, second to be 14, right? And then what would we probably do? Because we're solving an equation, right? It's not telling us to factor this or something. All we want are the solutions. Do we really need, is that 4 going to give us any solutions? So what could we do to both sides? Divide by 4, right? So we could just divide each side through by 4, and 0 over 4 is 0. It cancels the 4's, and we get a much smaller quadratic equation to deal with. We get smaller coefficients, which makes the quadratic formula even a lot easier to deal with, right? What might our shortcut have been? Rather than factoring out a 4, what could I have done? Just divide, right? I can divide. So here's kind of a really important rule, and I want you to listen very closely to this because it makes a big difference. Later on, we'll come back and talk a lot more about this. You can divide both sides of an equation by a constant, meaning a number, right? That's fine to do, but that's not going to change the outcome. But you cannot divide both sides of an equation by a variable. If you do that, things are going to get messed up. Like for example, if I had the equation x squared minus 4x equals 0, you might think, well, I could divide both sides by x and make that pretty simple, right? If I did that, if I divide both sides by x, I get what? X squared divided by x is x, 4x divided by x is 4, 0 divided by anything is 0, right? Does that make sense? And so you'd think, okay, well good, my solution is x equals 4. But we lost a solution, didn't we? Right? Instead, what I would have wanted to do here is to factor that, right? So instead I would have gone, factored out an x, leaving me with an x minus 4. And now if I apply the zero product property, what are my solutions? 0, or x equals 4. Well, we lost one if we divide both sides by a variable, right? So you can't do that, right? That's going to cause problems. But what we can do instead, we can, I just rolled back time, how about that? What we could do instead is just divide both sides by 4, right from the beginning, recognizing that 4 is the greatest common factor and it's a constant. And that would have brought me right to this equation, x squared minus 6x plus 14 equals 0. And I'm going to get the same solutions to that equation as I would have to that one, right? Just saves a step. Okay? See the difference though. If I had asked you to factor this completely and write it in completely factored form, well then I would have to include that 4, wouldn't I? Right? Because that is a constant factor. But if I'm just asking you to solve the equation, we just divide it away. We don't need it. It's not doing anything. Okay?
what would I obviously do here if I was trying to solve this one? Yeah, add 2x squared, add 2, right? Put it in standard form where it's set equal to 0, and then go from there, okay? All right, so for today, all I want to do today is I want to just talk about, we're going to move to the next step, which is which method should we choose? Now let's think about this. We could make like a flow chart out of this, right? And that's what I've got for you. So what if I gave you a quadratic equation where there was only a single x that you could point to? What do you do for sure? Okay. Say it again? Isolate the variable. Reverse PEMDAS and isolate the variable, right? For sure. That's easy. What if I give you one where that's not the case? Then what are the steps you'd go through? Like, so now you have an x squared term and an x term and a number, presumably. What do you want to maybe see first? What would be the easiest, quickest way to do it if possible? Factor. If it's easy to do, right? So if the magic numbers are easily accessible, then factor, because it's so quick and it's so easy. What if they're not? If either there are no magic numbers or it looks like they're going to be hard to find, like they're big numbers and you'd have to go through a major bottoms-up process, and then you probably don't even want to bother with that. What would you move on to? Okay, so then it splits, right? Then you get kind of you're going to move down and you got two other options left, completing the square or a quadratic formula. Now, completing the square can be pretty quick and easy. Now, when is it easy to do? If you look at our examples, right, if we're able to get something like, which of these, you tell me yes or no, is this an easy one to do, completing the square? If I can quickly get it to a form like this. Yeah, I don't even care what the number is, it's easy. How come? Because 4 is even, right? So half of b is an integer, so it makes the process really simple, right? Now, it's a little bit harder if I get something like x squared plus 7x plus some number, or if I get a fraction there to start with. Then, I mean, completing the square doesn't make it really difficult, but it's hard enough that you probably, move on, right? So you kind of get the, why we would maybe pick completing the square if it's just an easy thing to do, but otherwise we just default to quadratic formula. Exactly. Okay, so I've got two assignments that I'm putting up. One of them is going to take about 5 minutes, and one of them is kind of review for the test, which is coming up. So these are not colorful. The one online is much more colorful. You can look at that. It's, prettier to look at. But this is, put this in your notes. You may or may not even use this. Mm-hmm. So the first assignment, this is what all the questions look like. Oops, wrong one, darn it. So this is the kind of stuff you're going to get. All right, so looking at this quadratic equation, what would you do with this? You would subtract 4x, and then I'm going to get 2x squared plus 4x plus 12. If I divide by 2, I'm getting an even coefficient of x. So what would be good choices here for my... Can I call you right back? Oh, are you looking for somebody? Okay, bye. So what would be a good one to pick? Complete the square. Okay, so if I pick complete the square, Tells me great job. Okay, what if I pick something different? Let's try another one.
Mr. Grady.
Who's it for?
Grady.
Oh, okay.
They brought my Bible?
There you go. There you go. Okay, what about this one? So I'd want to obviously multiply through by -1, but completing the square would be a great option, right?
Yeah.
Factoring that's not going to work, is it? I mean, you might say quadratic formula. It's going to accept that too. Because quadratic formula in this case is, it's fine. But it's, in some cases, really it's not irrational to use the quadratic formula. So my point is, there are going to be some multiple cases where I'm not going to penalize you. But if I did pick something instead, like, whoops, I got to do it again. If I do pick something that's blatantly wrong, like in this one, if I pick, what am I going to get? X squared plus 6x plus 40. So if I pick something like factor, oh, never mind. I guess you can factor that one. I wasn't. So if I pick that one, right? Whoops. I'm so good I can't even miss one. Trying to. So on this one, I get x squared plus 5x minus. So directly isolate. How about that? Wrong. And I might get partial credit. And some of them it'll say, yeah, that works, but there's a better way. You might get like 90% credit on it. And then it goes through, and I've got some feedback that kind of reminds you why that's not the best one. Okay, so that's the first assignment. And then the second assignment is just a bunch where you are actually solving using the best method. So just 9 questions, and each one you're just going to solve it. If you get it wrong, the feedback is going to be written in terms of the best method. By the way, I did notice that, did you guys notice on the quadratic equation one, sometimes you got some weird feedback where it messed up and it kind of gave you some, it sort of blew up. Fixed all those, so if you reload questions in there, they'll be fine. They'll give you proper feedback. Everything's fixed. All right, have at it. You can finish today working. I'll give you a work day tomorrow. Kind of plow through this stuff. Get questions answered.